Okay, guys, this is natural logarithms. As you see today, we're going to talk about basically three things. I'm going to explain to you the natural log and its inverse. Then we're going to look, I'll show you that the rules are the same as they are for logs. And then we're going to look at some examples. This is not going to be as detailed because it is so incredibly similar to logarithmic functions that we've already practiced. You should be able to pick up on this pretty quick. So first, let's talk about the natural log and its inverse. So, log base 2, we've seen log base 10, we've seen stuff like log base 4. So logs can have different bases. Log could also have what's called base E, okay? And if a log has base E, we actually refer to that as the natural log. So in this lesson, you're going to be seeing a lot of just LN. This stands for natural log. So natural log has an inverse, and the inverse of natural log is E. Okay? So these will cancel each other out when I'm solving equations. Let's take our next step. And I have the rules are the same as logs. So what I mean when I say that is like with logs, for instance, if I have 2 log x, that's equal to log of x squared. If I have log of x plus log of y, then I can write that as log of xy. And if I have log of x minus log of y, I can write that as log of x over y. Okay, so we have those properties. They're the same for natural logs. So if I literally go in here and erase this stuff, I can do the exact same properties with natural logs. I could say that the 2 natural log of x is equal to natural log of x squared. I could say that natural log of x plus natural log of y equals natural log of xy. And I could say that natural log of x minus natural log of y equals natural log of x over y. So when I say the rules are the same, the rules are the same. Okay, so let's jump into some practice. I'll show you some examples. We'll also have some practice. So this question says, what is 2 ln 15 minus ln 75 written as a single natural logarithm? Well, the first thing I'm going to do is this 2 is going to become an exponent. So I'm going to put ln of 15 squared minus ln of 75. I'm going to square the 15. Go ahead and square that. So ln of 225 minus ln of 75. And that's going to get me ln of 225 divided by 75. I know 5 goes into both of these, so over here I'm going to simplify 225 over 75. If I just put 5 into both, I get 45 over 25. 5 goes into those again, and I get 9 over 5. So this is natural log of 9/5. Okay, so hopefully that looks incredibly similar to logarithms, and you're not surprised. All right, now let's go into solving, because solving I think takes a little bit more understanding. So what are the solutions of natural log of x minus 3 squared equals 4? What I'm going to do is I'm going to make both sides of these the exponent of e, because that's the base of a natural log. Okay, so this is very similar to what we did even yesterday when we were getting rid of logarithms. We made them the exponent of 10. So that cancels that out. And then I get x minus 3 squared equals e to the 4th. I'm going to take the square root of both sides. So x minus 3 equals the square root of e to the fourth, which is e squared. So x minus 3 equals e squared then. Then I'm going to add 3 to both sides. And x minus 3 is e squared plus 3. So that is how you solve a natural log. You basically just make it the exponent of e and then do the necessary algebra. What I would like you to do is I would like you to try these 3 examples. I'd like you to pause the video, work each one of them, see what you can do. And then I've got the solutions already written out to make the video faster. So you can kind of follow along. So like I said, pause right now, work these examples, and then when you hit play, you're going to see the answers. So I'm going to count down 5, 4, 3, 2, 1. And this is what you should have. If you can't read this one real well, down here at the bottom it says x equals e squared minus 5 divided by 3. So I'll write that over here. This says x equals e squared minus 5 divided by 3. Okay? Sorry you couldn't see that. I adjusted the page and it didn't adjust to fit back. All right, so the other thing we could do is we could have to break down an e function. So I'm going to show you how to work an example like this. The first thing I'm going to do is I'm going to isolate this right here. Oh, don't want to write on that. I'd rather highlight. So highlighter, I want to isolate this right here. Okay, so I'm going to say that 4e to the 2x equals 14. What I've done is I did 16 minus 2 to get 14. Now I'll divide by 4. And 14 over 4 is really 7 halves. So I have e to the 2x equals 7 halves. Now I want to cancel this e function out, so I take the natural log of both sides. And this cancels. So I have 2x equals natural log of 7 halves. And I will divide by 2. So natural log of 7 over 2 divided by 2. And there's my answer. Okay? So isolate your e function first, and then use natural log to cancel out the e. Same thing, I'm going to give you some practice examples. I'd like you to pause the video at this time and try to work each one of these. And then when you're done, hit play. And in 5, 4, 3, 2, 1, here are the answers that you should have gotten. And so hopefully now you see that working with natural logs is no more difficult than working with logarithms. So hope this went well. Hope this video was a little bit quicker than the ones in the past. And good luck to you, and do the practice work in Canvas now.